Okay, so today I want to take a look at a 50-inch Hisense. All right, this TV I believe is a dead set. I've never looked at it before or opened it up. The model number is right there. It's a Hisense 50 for 50 inch, D as in David, U as in unicorn, DU 50 DU 6070. All right, see, it was manufactured in 2017, so almost 5 years old. Okay, so I'm going to plug in the AC. Okay, got it plugged in. Isolation transformer is on, and we obviously should be getting a standby light here at the bottom, right? Whether it's red or blue, I'm not sure on this one, forget. Okay, and we have absolutely nothing. And then when I hit the power button on the back, hopefully you can see that. This one is power. When I hit that, absolutely nothing. All right, no standby light, nothing. Okay, so let's take this bad baby apart and see what's going down. Okay, so what I'm gonna do now is I'm gonna double check, make sure the standby light isn't coming on, because I can see behind it now, because sometimes these lights will fool you in certain light. You'll think it's not coming on, but it really is. It's just so dim. So I'm just gonna double check it and look at it from the back right here. Okay, I'm gonna plug it in. Power. Okay, that is off. No doubt, it is not coming on. The light, standby light is not coming on at all. All right, so unplug it. So first thing I normally do in a dead set, right? No standby light at plug in, nothing. All right, is check the fuse. Okay. And as you can see, this is our AC fuse right here. Obviously, I'm gonna have to pull the board out to check that, because this is a fuse with the 2 pins that are soldered up underneath. So I would normally check that first, and then if the fuse was good, I will go ahead and check for my standby voltage. But since I gotta do a lot of work to, take the board, well, it's not a lot of work, but since I gotta do extra work, right? Pull out all the screws out of the board and flip it over and check it. What I'm going to do here is go to this plug here. Okay, that's going to obviously the main board, and I'm going to see if we even have any standby voltage. Because if we do, then we know our fuse is good, right? So if we don't, that means I'm going to have to, pull the board out and check the fuse or whatever else is around there. So what I'm going to do is I'm going to check at this plug right here on the secondary or cold side of the power supply, going to the main board, and I'm going to look and see if I can find where our 5-volt standby. I think it is even labeled right here. There's a legend next to it. Okay, so I can get that on camera. And there it is, STB, standby. Where we at? Let's go down, 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 right there. Okay, that stands for standby, between the ground and 12 volts. If it's not marked on the board, just check all the pins, okay? Make sure you check them all real good, okay? And use a chassis ground, since you're on the cold side. Just take your positive lead after it's plugged in. Plug the TV in first, and then make sure that you check each and every pin. If you got a steady 5 volts or 3.3 or whatever standby uses, then there's a good chance you got standby, okay? There's nothing wrong with the power supply board, all right? Some of those pins aren't used. They're empty on this particular board. Okay, so first two is no connection. Then we got ground, then bright. Looks like there's actually 3 or 4 missing pins. But if you can't figure it out, like I said, just check all of the pins with your meter. Okay, put your meter on DC volts and check to see if you have standby after you plug in the power to the TV. All right, or you can always use the ground method, which I do is I just see which one is ground. Okay, label ground. And I just go right to the pin and just kind of like can figure out, see which one is pin 1 or whatever. I'm just gonna go to all the pins and see if I have any DC volts or standby on each one of those lines. So I'm gonna plug it in, plug in the power, and I've got my native lead of my meter. I've just got it grounded anywhere on the metal chassis. It's fine, anywhere. I see some little holes here. I'm gonna start with this one down here. This pin here. Nothing. Pin next to it. Nothing. 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 Make sure I'm getting up in there. Okay. Nothing. 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 And if you want, just to make sure, you can double check a few more times, okay? Just to make sure. Okay. Meter's on DC volts, I'm grounded. Nothing there. Nothing there. Nothing there. Nothing there. Nothing there. All right. We have no standby. Let's actually see if we have any voltage on the big filter capacitor. We should have approximately, the TV's in standby, 167, 68 volts, 69 volts, right there, big filter capacitor, right here. Okay. All right, so I'm gonna be very careful because I got it plugged in still. And I'm just gonna go across it. Just make sure that you do not short the leads out, all right? Right here, this is negative, as you can see, facing towards you. All right, and the other side is positive. Okay, I'm gonna keep my meter in DC volts, TV's plugged in. I'm going to see if I have any DC volts on temperature meters in DC volts. I actually got 377. All right. I'm gonna go over here to this optocoupler. Okay, let's go to the, whoops, I need to go to hot ground. Okay, be very careful. Make sure my lead is steady on hot ground and go to the other side of the optocoupler. Okay, we have some, you see that? That is on the primary side of the optocoupler on the feedback line. Okay, which lets me know that we have a problem, all right? So, I'm gonna unplug it now. And, all right. So this pin, I'm gonna go to this pin, I'm gonna go to the hot side of my capacitor, and that is ground, right? And I was getting a fluctuation of about 1 volt on this pin. So, which means we're getting closer to figuring out that we have something that's trying to come on, but it's not working. So I'm gonna take this board out, flip it around, and let's see what we get. Okay, I got my power supply turned around, and mainly what I want to do is I want to identify what's going on and how is it working. All right, so evidently we have our main switching transformer right here. As you can see, one side of the transformer is on the primary side, and one is on the secondary side. Okay, so it's our main switching transformer. This is obviously for our power factor correction control. Okay, now we was getting to 380 volts, so the PLC circuit must be working. All right, so we need to find out what's going on here. Okay, why we're getting voltage fluctuation, why we're not getting secondary voltages, obviously because this switching circuit is not working. So we have to identify what is switching this transformer. Okay, so evidently we've got two FETs. Okay, most likely we got three FETs here. I'm sorry. So one of these FETs evidently is for the power factor correction circuit, which I believe is this one, and the other two are for switching this transformer here. Okay, and one is low and one is high, and they both reverse. And this is the main primary switching transformer right here. Okay, and as we see on this pin right here, we see that it is going to this FET right here. Okay, and that is going to this FET right here. That is going to the the drain. That is going to the source of the other FET. All right, so we know that these two FETs are what's driving this transformer. Okay, thus this transformer is producing the standby or voltages. We'll need at least standby, but we're not getting that. So something's going on here, and obviously, if I trace the gate of these FETs right here, it is going to this IC for the drive signal. This one is going somewhere over here, and this one is going somewhere over here. Okay, so first things first, right? Let's see what is this doing. All right, so this is right here, that actual black IC, driver IC, is this IC right here. This is a digital multi-mode PFC and LCC combo controller. Okay, so basically it's a controller. It's a integrated PFC controller and the driver also for the other FETs. Okay, for, as you can see, we have VCC, which if you're watching my other videos, you definitely want to check that. Matter of fact, let's go ahead and mark this. We need to be checking. All right. VCC pin, which is pin 3. Okay, we need at least, I don't know, 11 to 18 or 20 volts is usually there, steady. All right, we also have another VCC, okay, because remember this IC is used, it's a combination IC, so yeah, we may need two VCCs to get to start working for the PLC controller and also for the main switching transistors and transformer, right? And then we have gate drive. The gate drive here. All right. And we should have two more because we have three, because actually, like I said, we have three FETs or transistors, right? Three FETs. We're saying they're FETs, and we need three driver out to the gate pin. Okay, so here is one right here, high side gate driver. Okay. And let's go down and we see gate driver 1, GD1. All right. It's a description of each pin. And pin 1, what does it say? Gate driver output, PFC gate driver, right? PFC gate driver, okay? And if we go down, where are the other two pins at? Right here. I got marks on it from the other side, don't worry about that. We see pin 12, GD1. Gate driver 1, half bridge, and high side gate driver. So that's for the other FET, okay? So we got our 3 FETs being driven by the one IC. I'm pretty sure we do have a signal here because we do have the power factor correction circuit is working. So what I'm going to do is I'm going to actually go to pin 1 right fast with my, see if we got some type of signal. And obviously this doesn't use a BNC connector, so it's not going to be super accurate to try to do math on the signal, but it's going to be good enough for the eyes, right? Okay, that's pin 1, all right? That's where our dot is. You can barely see on the IC. And if you want to double check it, you could just use ground, the ground pins, because evidently, let's see where it's ground at. Ground is pin 4. So I put my meter in continuity. I can actually find pin 4 should be 1, 2, 3, 4. Go to the negative side of the filter capacitor. That is ground. Okay, so that is pin 1. 1, 2, 3, 4, all the way to pin number 8, and then 9, 10, 11, 12, 13, 14, 15, 16. That's how you do it. Let me just show you again where we're getting the 380 volts. I go to the capacitor once again. Okay. And where are we at? Right here. Got it marked. It's good. 377 volts. That should not be fluctuating that much. All right. Maybe not at all. Okay. So if I go to pin 1, that's the gate driver, which is this right here, pin 1. And I'm going to go to my ground on the capacitor and pin 1. I'm going to have to hold it here for a second because, oh, there it goes. There we go. Yes, we do have a signal there. Okay, like I said, this scope is, try this again. There we go. Try it again, auto. There we go, that's a little better, you can see it now. All right, so we got something going on. Like I said, it's separated slow. GD1, pin 12. Okay, so that's 16, 15, 14, 13, 12. Get something there. All right. Okay, now let me just go to the VCC for this IC. The VC, we got 2 VCCs here. One is pin 3. All right. Hopefully you can see that. One is pin 3, VCC, and the other VCC, and you can always read these descriptions, would be, where we at? Pin 15, high side VCC, and power supply for the floating driver, supplied via bootstrap. So I guess both VCCs are coming from the same source. Man, it must come with age, right? Pins 3 and pins 15. Okay, let's see. Pins 3, 1, 2, 3. That should definitely not be fluctuating. And then high side VCC would be pin 15. Should be right here. Okay, they are both fluctuating. All right. So next thing we need to do is find out what is feeding. I'm gonna plug this. is feeding these VCCs. So all I'm gonna do is I'm gonna trace it to find out what the capacitors are. I'm gonna check those capacitors for the VCC, and usually there are only a few capacitors in that area, and they're usually were between 47 microfarads. Around 47 microfarads are usually the capacitors used for the VCC for whatever driver chip it uses. All right, so actually got two here. All right, and we got one here. All right, so let's just check these right fast, okay? And one of these obviously is for probably something in the startup circuit, and the other ones are for the VCC. Which is only three. We'll just check them all, make sure they're good, eliminate the capacitors being bad, right? Okay, so what we're doing here, capacitor, and I just looked at them. They are all 68 microfarads, I believe. 68 at 50, and this other one is 68. Okay, so we go for this one first. And you should be able to check these in the circuit. It's not too much stuff in series with it. Or I'm trying to say parallel with it. Come on, 68. Uh-oh, wait a minute. I'm on the right one. Here we go. Okay, let's try this again. Okay. 71 microfarads. Good. All right. Now the other two are in parallel. Okay, these two here. Right? So like I said, I'm checking the caps on the primary side. All right. So let's see what kind of reading we get on these. So those are in parallel, should add up. So 68 is I don't know, about 140, 130 something. Let's see. I'm just gonna go across one. $140. All right. That, what did I say? 68. Yeah, that's about right. 70 and 70. 68, 68. It's about 136 or 140. It's good enough for right now, right? Now what I want to do is I want to check if there's anything else in the circuit. There's usually a diode. I just want to double check that that's actually feeding the voltage, right? For the VCC. All right. So this is our IC, IDP23. This has an 01, but when I went to pull up IDP2301, I couldn't find anything but IDP2303. So evidently it's most likely the same or similar. But this is used in a circuit, right? And if I actually follow and see where my VCC should be coming from, right here, high side VCC. Okay. So I'm trying to figure out where the capacitors are. VCC, these are our capacitors right here. This is our main diode, all right, right there. Okay. We'll find that. That might be an IC too. Let me see here. D20. Okay. All right, well, since both of these are switching, fluctuating, the VCC and the high side VCC right here, right? I'm trying to look at this on camera and trace it. So. All right, okay. All right, and then we have this going out also to the capacitors, which is right, and that's the diode right there, okay? So anyway, what I'm gonna do is I'm gonna actually check. I'm gonna trace this back. So these are the two capacitors, I guess, all right? And these are diodes. They're using two diodes here. Let me see if this one is, make sure it's not shorted anyway. And reverse bias my leads. Looks good to me. All right, okay. Now, let's see what else we got in the circuit. Okay, start with VCC, that's pin 3. All right, so pin 3, I'm going to go right here. 1, 2, 3. Let's see where this is going. Okay, 1, 2, 3. All right, it's pin 1 right here. My blue at it's pin 1. So 1, 2, 3, and that's going to that capacitor. But I can't see where else it's going. Let me see. It's going here. All right, let me see if it's going. This should be a cord. Okay, that's a capacitor. Okay, it's going there, and then this one goes from here to here. So both of these are connected in parallel. These two capacitors. So we're going from here to here. That's pin 3. So that diode, let me just go ahead and leave it right there. Use this hand, and this diode, this capacitor right here is going through what looks like to be a burnt resistor. Okay, and there's a diode right there. All right, and this other end of the diode is going right to, just like pin 15, right? The anode of the diode is going to, let's see, do it like this here. Pin 16, 15. Okay, let's check this diode right fast. Okay, 74 ohms. All right. Now, as you can see, I did take one end of the diode out, and it was still reading low. I'm going to show you what I got on my meter. It's reading 74 ohms across this diode right here, both ways. Okay, which is evidently not. This was being used to bootstrap both of those VCCs. All right, so come on. Right there. Okay. 0.07. That diode is practically shorted. This resistor right here should be 10 ohms. I'm sorry. Should be 10 ohms. 100. 10 multiply at 0. But we got 40K. Okay. 470. That's supposed to be 47 ohms. And 1002 should be a 10K, right? 2 zeros on the end. That's the last number is a multiplier. This one is burnt, and this diode is reading short, almost short, right? Not getting a good reading. All right. So actually, what I did, as you can see, I took the diode out. I didn't replace it or anything. I don't know. That's the only problem. I took it out and rechecked it. That diode is reading the same way when I took the one side out. I took the whole diode out, okay? All right, so I just put the diode back in just to start from the beginning on this TV right here. So what I'm gonna do is, luckily I had another Hisense board that uses the same, it's not the same board, but it uses the same controller IC. All right, actually it was a 2303. I don't know why this is a 2301. I'm not sure. If anybody has any hints or anything, leave me a comment in the comment section. But uses that same bootstrap diode, okay? And that one was a MUR 160K. All right, it's a fast recovery diode. You can look it up, the data sheet or whatever online. And I just want to show you that even on this sample circuit diagram. They're also using a 10 ohm resistor. I can't zoom it in any closer, otherwise it's going to get blurry. See, 10R. Okay, so let's change both of those, and hopefully, with any luck, we will be all set. Okay, we've installed our fast recovery diode, the MUR 160K, and our 10 ohm surface mount SMD resistor. Okay, so I'm gonna go ahead and plug her in. Come on. And what I'm gonna do first is go ahead and check my VCC voltage, which is fluctuating very badly. Okay, pin 3, 1, 2, 3. Let's see what we get. Now we got 12 volts, and it's not fluctuating that much. All right, it got a little fluctuation on there, but much better than before, right? One thing I forgot to tell you guys about is how this IC starts up. It uses HV, high voltage pin number 8. Okay, right here. Okay, that's coming directly from the power supply. Through some diodes and a couple resistors, I think. Let me see, pin 8. It says high voltage input connected to the AC. Pin HV is connected to the AC input via external resistor and 2 diodes. Let's check that. Now before I checked it, it was fluctuating very badly. And let me see. That's pin 8 on the other end of pin number 1. All right, same side, okay? There we go. And that is a steady 112, pretty much. All right, so let's see. So we know our VCC is stable. Our startup or high voltage is stable. Okay, at 112 volts. All right, let me just go to, oh, you know what? Let's check the capacitor. The main filter capacitor. 346, 345, 346, 345. Okay, all right, well, at least it's more stable now, right? I'm just gonna go to the cold side, our secondary side, our output, and this is our plug. Okay, going to the main board. We should have some type of standby voltage on one of those pins. Okay, so I have to ground now. I have to use, because I'm on the other side of the transformer, okay? I'm gonna have to use cold ground now, which is any one of these. Since the board is unplugged from the TV, it's not screwed in. I'm gonna have to use one of these little rings that the screws screw into. It's all metal. So let's start where it says, it is actually marked on the bottom of the board, STB, okay? And I put my meter there. I don't get anything, all right? I'm see if we got some kind of DC voltage across here. All right, it's coming from the transformer right here. One volt DC. 172. We got DC voltage now. All right. Okay, let me just double check these pins. Let's see, this one says 16 volts. Whoa! I got 17 volts there. And that is steady, right? 16.9. It's 16.9. Okay. I don't know what this says. I can't read that. It's like ground. Okay, ground. Standby. Nothing. 12 volts. Wait a minute. We got something there. Let's see. Okay. 12 volts again. All right, and these other pins are not connected, right? Yeah, these are the ones that are not connected on this particular TV. Those pins are empty. So that's kind of weird. Let me go back here. I got 16 volts, but now this may be one of those cases where you have to get where you have to plug in the main board to get a standby voltage. But we are getting some type of voltage there, 16 volts, and it is not fluctuating, 16.9, 16.8. All right, so some of these TVs can be kind of funny. Let me just see. I'm gonna go ahead and plug it in, because that 14 volts or 16 volts may be our standby voltage, right? Okay, you check out the board unplugged, and I'm gonna go across this capacitor, this main filter capacitor, right here, okay? And it was at 300 volts when it was plugged in, but watch it now. It was negative, but it doesn't matter. Let me see. We still have 200 and some volts on there, and it's going down, right? Okay. So you're probably gonna wait about 5 or 10 minutes before you start touching the board. But anyway, since I know what it feels like to get shocked, it doesn't make me no difference. I don't like it, but okay. All right, and we see we have a plastic cover, I guess protective from the chassis. I'm gonna line my holes up correctly, making sure I don't put it on the metal part. Please don't do that while the capacitor still has a charge on it. All right. All right, so soldering on that board, even though it wasn't plugged in, and my solder, which I had like this, had like a long piece in my hand, and the piece right here hit something on the primary side, and I saw something spark, and then it blew out 2 FETs and some resistors. And we didn't have any standby, but we had the 14 volts. That seemed kind of weird. We should have standby before anything. I'm gonna look and see at my standby light, see if that even comes up or whatever, right? So our standby light, and this little piece of glass or plastic right here. Sorry. So let me plug it in, plug it in, plug it in. Oh, I got a standby light. Probably can't see that on camera. Or can you? Let's see. There we go. Standby light. Right? Right there. So far, so good. Probably not gonna come on. Let me see. Power. See if that light. Too much light here. There we go. See a little better now. All right. All right. Let me go ahead and hit the power button. One of these buttons, anyway. Oh, a light went off. Oh my God! Look at that. Look at that. Guys, looks like we are in good shape, right? Looks like it's flashing on my screen, but it's actually not. Just the camera, the shutter speed. Well, anyway, I'm gonna hit the menu if I can find it. There we go, guys. Oh, what happened? Oh, there we go. Okay, just the menu disappeared. I'm gonna grab my meter. Since I got the board screwed in to the chassis, I can use the anything metal for checking voltages on the secondary side, the output side. Okay, on this part of the line. Okay, and let me see. That's ground. That's ground. PWM. Is that what that says? PWM. All right, we got 2 volts. Switch. Probably switch the backlights on. Should be 2 to 5 volts there, I guess. 4.6. Okay. All right. 12 volts. Same one. Okay. 12 volts is good. It was rating 10, but it's 12 now. Okay. Now I put it at standby. I got 3 volts, and as long as these 2 numbers are not fluctuating, the 0 and the 2, that's good. I got my meters in the 5 count range or 4.5 counts. But yeah, that's good. Okay, and 16 volts. Where are we at? Am I looking at this wrong? Okay, standby. 3 volts. Ground, 16 volts. I don't think those were being used. Yeah, there we go. 16 volts. Running steady. Alright guys, so if you like the video, make sure that you do subscribe. Well, if you like the video, give me a like, okay? Then I want to say, yeah, make sure that you do subscribe, okay? You have nothing to lose. And as far as that goes, I will see you guys in the next one. Big Dog out.
To the Mr. Robert, Mr. Big Dog.
Yeah, this is him.
Yeah, how you doing? My name is Billy Joe Whitaker, and if that name don't ring no kind of bells to you, you don't have my TV over there for almost 6 months. Now, I want to ask you a question.
Sure.
I don't know what kind of outfit you boys running over there, but is my TV serving some type of prison sentence? Why you had my TV for 6 months?
Well, sir, like I explained to you, we had ordered the parts for the first time.
Okay, let's slow down for a minute there, sir.